Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be covering propositions 5 through to 12 of Book 7 in Euclid's Elements. So let's begin. Now, proposition 5 says that if you have two numbers, a and c, which are equal to a certain part of two other numbers, b and d, then if you add them, then the sum will be the same part of the original numbers that were added. So basically what he states here is correct, okay? And also proposition 6 tell us that both 5 and 6 tell us that several proportions exist. That is, so for example, if you said A divided by C, that would equal to B divided by D, okay? That's what it tells us that, and it tells us that A divided by B is equal to C divided by D is equal to 1 over n, which is the fraction of both B, the same fraction of both B and D. And also that A plus C divided by B plus D is equal to 1 over n. So like I said to you, oh, by the way, this here again is based on, this last statement is based on proposition 12 of book 5, and you'll see it coming up again and again and again, okay? Now, so as I've told you before, the transition to number happens from book 5, okay? A lot of these things you'll see in book 7 again, even though they've been covered. Some of them have also even been covered in book 2. So for example, in book 2 you have a similar proposition to the one that you have in book 7, okay? Not proposition 5, but one of the previous ones. Let's just see here. No, okay. So I'm thinking of book 5 only, not book 7. All right, so propositions 5 and 6 are basically telling us that several proportions exist, and they're not very difficult to understand because they're being covered in book 5 with magnitudes, not with numbers. So proposition 6 again, proposition 7 through 10 concern similar results using the difference operator rather than the addition operator. So what you see Euclid doing here is really setting down all the rules for algebra, okay? So in other words, what kind of operations can you do with algebra? And it all starts with a simple ratio and a proportion, okay? Now, proposition 11 begins to define ratios between numbers, okay? So now remember, we had these ratios in book 5, but they were not ratios between numbers. They were ratios between magnitudes. Now with numbers, you have the same property, but there are certain magnitudes that have no measure. So if you had a magnitude without a measure, let's say for any of these, then it wouldn't be a number. It would be an approximation of that particular magnitude, okay? So for example, let's say a was pi, then in this case here you couldn't really write down this ratio if a was pi, okay? It would only be possible in a approximate form. So this proposition again is equivalent to proposition 12 of book 5, but using numbers rather than magnitudes. And notice very carefully that if 0 were considered a number, the proposition would not hold. So for example, if you started with 3/4 is in proportion to 9/12, and not only in proportion but equal in algebra, not so in book 5 where we deal with magnitudes. So if you keep subtracting 3/4, 3 from the antecedent of the second ratio and 4 from the consequent of the second ratio, and you carry on doing this, you'll end up with 3 minus 3 as a ratio of 4 minus 4, which is not allowed in Euclid's elements, okay, because 0 is not a number, right? So proposition 12 of book 7 is similar but uses addition. So it uses this particular, it also uses proposition 12 of book 5, but uses addition rather than difference in the ratios of numbers, okay? So we've covered the first 12 propositions, and in the next video I'll continue off where I left this time, and hopefully I'll be putting out another video soon. I intend to do a few critique videos, so I may not immediately resume with book 7, but I'll keep going back to it at some or other stage until I'm completely done with it. So if you're not already a subscriber, become one. Also remember to visit that new math channel that I recommended. It's going to be a very useful and brilliant channel. So that's pretty much it. My name is John Gabriel. This is New Calculus Channel. Till next time, goodbye.